All right, so I go ahead and plug everything into my equation right here. I'm going to cancel my units, which is going to leave me with moles, which is what I'm looking for right here. So I get 0.00288 moles, and this is of H2S. Okay, now that I've got moles of this, I can go moles to this, grams. So the rest of this is just going to be stoichiometry like we already know. So I'm going to erase this. So I'm starting with 0.00288 moles of H2S. I need to get to moles of this. Moles of Ag. Okay, H2S. So I'm going to use my coefficients, a 2 and a 4. And if I plug that in, I get 0.00576. And that's moles of Ag. Okay, last step is to go from moles to grams right here. So 0.00576 moles of Ag over 1. So I know 1 mole of Ag is going to be equal to, now all I have to do is go look for grams on here. My silver is right there, number 47, and it is 107.9 grams. So my answer is going to be 0.622 grams of Ag. Okay, so really I just started with what I knew, used PervNert to find my moles, and I could go moles to moles, moles to grams. Okay, let's do the last one. All right, so number 10 says, one common rocket engine uses the following reaction, and then it gives the reaction. Oh, hold on. All right, so number 10 says, one common rocket engine uses the following reaction, and here it is. And then it says, this rocket engine contains 1,500 grams of H2O2 and an excess of N2H4. What volume of water vapor will be produced when the rocket fires up to this temperature with this pressure? Okay, so let's start. We're asking ourselves, what do we need to know? What do we need to find out? Okay, so they said the volume of water vapor. That's what we're looking for. So if I look up here, I see this is water. It's a gas, so this is water vapor. Underline it and put a question mark for volume. That's my end goal. And then what did they give me? They gave me 1,500 grams of H2O2. So I'm going to underline that. That's going to be my starting point to get over here. So I'm moving all the way over. Okay? So I know right away I need to get to moles here in order to get to moles over here. Okay? So my main goal is moles. What will give me moles? Well, they gave me grams of this H2O2. I can find moles easily, okay? So 1 mole of this is equal to this many grams. So I'm just going to go up here, find my H, find my O on my periodic table, and I find that it's 34 grams, okay? So if I crunch this out, I get 44.1 moles of H2O2. Now that I'm moles here, I can go all the way over here with moles. So 44.1 moles of H2O2. Moles of H2O2. Moles of H2O. Be really careful labeling these. They look very similar. I don't want you guys to get confused. So this one's going to be 7, and over here the coefficient is 8. So I'm going to crunch that out. I get 50.4 moles of H2O. Now, I made my way over here. I've got moles. I'm looking for volume. Okay, and then they also gave me a temperature and a pressure. So you should be able to see now, aha, I can use PervNert, my ideal gas law, because I've got moles here, temperature, pressure, I can all plug it in. So let's go ahead and erase this. All I really need is this last answer right there. So off to the side, I'm going to list these. I'm going to plug my N in, I already know that, so I don't forget moles. and I'm looking for volume. So I'm going to volume question mark. I already know my R is 0.0821 atmospheres, liters, moles, Kelvin. So I just need to plug in my pressure and my temperature. So it looks like our pressure is 1.2 atmospheres. And our temperature, we started out at 540 degrees Celsius, 540. And now we are adding 273.15. We can just get rid of that. So we end up with a temp of 813. Okay? So now I just need to move things around. Pervnert. I'm solving for volume. So I'm just going to move the pressure. So now I just need to plug things in. Let's get rid of that. So I've got my moles, 50.4 moles, times my R, my constant, 0.0821 atmospheres, liters, moles, kelvins, and temperature, which is 813 kelvins, over my pressure, which is 1.2 atmospheres. Okay? Cancel your units, moles, moles, kelvins, kelvins, atmospheres. I'm left with liters up here, which is good. I crunch that through and I get 2,803.39. I can only have two significant figures here, so I'm going to move this. So I get 2.8 times 10 to the third, and that is liters. Okay, so we just did opposite this time, really. We used our grams, we went grams to moles, moles to moles, and then on the back end, we used Pervnert to find our volume for that. Okay. All right, so before I let you guys go, we worked through the review questions and the practice questions, and I just have a few things I want to remind you of before the test. You need to know what Charles' law, what Boyle's law, what Dalton's law really state. Remember Charles' law, when we've got volume and temperature, remember this is kind of when we talked about the absolute zero scale, right? If the temperature decreases, the volume of that gas is going to decrease. Just like if the temperature increases, the volume's going to increase, which makes sense. If you heat up a gas, it's going to be boiling around a lot more, and it's going to, if the pressure stays the same, the volume's going to be able to go up to increase to keep that pressure the same. Okay, so that's Charles' law. Boyle's law is opposite, it's inverse. Okay. Also, you're going to need to know your units of pressure. We talked about that. The pascals, kilopascals, torr we used a lot. Atmospheres, millimeters mercury we didn't use quite as much. Also, why is the Kelvin temperature scale called absolute zero? So it has to do with this. Remember, as this temperature goes down, okay, what happens to your volume? It also goes down. Well, when you start getting cold, 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 can you ever reach 0 degrees Kelvin? No, it's called absolute zero for that reason. Because the second, theoretically, if you were to hit this 0, your volume is also going to hit 0. And when that happens, you have nothing left that you're working with. There is nothing there. So that's why you can never reach that 0. And that's the same thing as negative 273.15 degrees Celsius. So you can't ever get down there, okay? The definition of a boiling point, remember, when you've got your container, okay, and you heat it up, those gases start escaping and they have a vapor pressure right here, right? Well, when that vapor pressure is equal to the atmospheric pressure outside here, when they're equal, that's what we consider the boiling point, okay, is when all these start coming up and they're the same pressure as the atmosphere. And last, remember the whole idea behind extrapolation. You have to have a lot of data, little bit of extrapolation. Okay? All right. For next week, go ahead, take your test for Module 12. Go ahead and read Module 13, and then we will walk through the lesson together, and then you can do the on your own after or during that lesson. Okay?